Okay, welcome to my Smarter R playlist YouTube channel. So today I will show you how to calculate relative important matrix by using relaimpo package in R. So let me share the screen first, entire screen, and then let me put me down here. So this is the paper that I have published in February 2024. So I'm applying relative important matrix to rank the GCM model to select the best GCM model for Johor River Basin in Malaysia. And I found out that based on this matrix, XS SM15 and CMCC SM2 is the best model. So this tutorial, I will show you how to calculate this relative important matrix. So let me go directly to the tutorial. So this is the tutorial. So make sure, so what we are going to do is we will use a relaimpo package. So if you don't have the library relaimpo package, you must install it first. That library first, you must install it. And then I have already installed it, so it's okay. So based on this relaimpo package, we will calculate relative important matrix. So there is 7 matrix that we use. We use to rank of the GCM based on 178 grid point here by using CHIPS dataset. So each matrix will rank each grid point for 178 grid. So let's see our data set. So I have this data. So my data is actually I'm written it's a little bit weird here. So I put my grid file is actually I read loop took all grid from grid number 1 until 178 from this file. So because I have IPM, I have 178 grid point. You see, there's a lot of data set here. So each of this grid point is actually the GCM. The GCM, you have V1. You see, I have here V1 until V24 is actually the GCM. The GCM that I use. I have 24 GCM. And this is actually from first column is daily dataset. So if we see here, from I think this one from 1981 to 2023. You see, so this GSM is actually from 1981 to 2023. So that is how the data is arranged, but I just put number here actually because the date is not important, because we want to rank which GCM of this 124 GCM is the best for the grid number 1. That is what we want to know. So we have that arrangement of GCM for 178 grid. So you must arrange your data like this. For each grid point, you must arrange daily data set for each of these GCM. So I have 24 GCM for each grid point. So we have that data set. Now we run our model. First, we function to perform relative important analysis on our given data set. We analyze the grid by using function, grid file, output file. So we have this grid file and output file. So my output file, I will rename it as RIPM special grid because we have 178 grid just now, right? So it will read the number tentatively. And then it will produce output data, relative important Peninsula Malaysia spatial grid. So this will be the output. So output file. So data, we read the CSV file, grid file. Just now, this is the grid file we will read down here. And then we read the data from second column until the end. So each of this input data just now, so we will read the second column until the end. So we have 24 GCM. So now we start using relaimpo package. We fit the linear model. So by using linear model V1, so we have V1. We have this data set just now. The input data column heading is V1. So we V1 until the end, until V24. So data is equal to here is as vars. And then now we calculate relative important. So this method, this code is actually I have summarized. I make it very simple, just not very extensive compared to the code in the package. So we calculate relative importance by using calculate relaim, calci.relaim here. So we read the linear model, fit linear model just now, and then we'll calculate each of this uh, each of this matrix. So relative important, they have many matrix. They have LMG, last, first, beta skew, Pratt, Genesi, and car. So you can read my paper actually just to understand all of this matrix. So and then we close it and then we put rela equal to true. And then extract the relative important measure. After we calculate this one, we extract the result. So we calculate and then I'm combine all the results so that all the data will be in the correct order, like LMG, last, first, beta skew, Pratt, Genesi, and car. And then we write the result based on CSV. The result will be the output file here. So we analyze the grid and then we loop this input then output just now, and then we will get our result. But I will not run this code because it will take quite a long time to finish. So I will just directly show you the result. So the result will be relative important spatial grid here. So relative important PM spatial grid. Okay, this one. So I will also have 178 result output. So each of the grid I will analyze the GCM and then I will get this result. So this is the first column is actually V1 until V23 just now, but it is not appear here. So actually this is GCM number 1 until GCM number 23. So this is the ranking of the GCM. So if we rank this like just to see the result, we will find that the best I don't know the maximum or minimum is the best for LMG, but it seems here like V9 is the best, maybe the highest is the best, something like that. So under this LMG matrix of relative importance, V9 is the best. And then if we look at this last matrix, let's see, it's also show V9 is the best. So this is how we calculate relative important matrix by using relaimpo package. So you will get each of this grid point result. Each grid point will tell you which GCM is the best based on each of these matrix. Now that I will show you, just calculate it. After this, you need to aggregate all the ranking or something like that. If based on my paper, after because we have a lot of 178, right? 178 time 24 is so many results. So you need to use CPI, compromise programming index here. CPI to aggregate the ranking, and then you will get which GCM is the best under each of these metrics. So I hope this tutorial will be helpful. So this is the very short short code that I have developed compared to what I used previously. It's very long long coding. Now it's very simple like this. So I hope this tutorial will be helpful for everybody. Thank you for watching.